Guys, welcome back. So what we're looking at today is 2.7 logs go viral. So let's go ahead and jump right in. So we want to fill in the table for each of the given functions. So we have x to the first power. Hint, x to the first power just means whatever your x value is, your y value is the exact same thing. The exact same thing. So it's giving you the answers in the problem. X squared, remember, that just means that you're going to take your x value and times it to itself. So -3 times -3 is going to give us a +9. -2 times -2 is going to give us a +4. So on and so forth. So over here, just as a reminder, they're going to be the same. All right, for x to the third power, that means you're multiplying your x value times itself 3 times. So -3 times -3 is a +9, but +9 times -3 is a -27. So we have -27. -2 times -2 is a +4, and 4 times -2 is a -8. So on and so forth. X to the fourth power, that means you're multiplying it 4 times. So -3 times -3 is a +9, times a -3 is a -27, times a -3 is a +81. So when you have an even exponent, your answers are going to be even, no matter whether it's negative or positive that are going into it. When you have an odd exponent, if you have a negative number that you plug into there, you're going to get another negative. So -2 times -2 is a +4. +4 times a -2 is a -8. -8 times -2 is 16. And -1 times -1 is +1. Times -1 is -1. Times -1 is +1. So we'll go ahead and do all of 4 together. So 0, no matter what, is just going to be 0. 1 is going to be 1. 2 is going to end up being the same thing as -2. And 3 is going to be the same as -3. So on your x squared and your x to the fourth, your values are going to be the exact same, and the same signs. On your x to the first and x to the third, your values will have the same number, but it's going to be positive when they're positive, negative when they're negative, okay? All right, for number 6, identify the points that all the functions share, explain why it's logical. So look through, once you have these all figured out, see which values they have in common, explain why, and then talk about how the functions contrast the graphs of the even functions with the graphs of the odd functions. So explain what differences they have. Specifically, look at those differences. And for number 5, it does want you to label each graph with the function that describes it. So note this red line right here, that's going to be the y equals x to the first. So just a little helpful hint there. This purpley pink one right here, that's going to be our y equals x to the third. So our y equals x to the fourth and our y equals x squared, they're going to be the green and this kind of navy blue one. So you have to figure out which one is which, okay? I'm going to leave that to you guys. All right, a certain bacteria population is known to double every 15 minutes. An experiment is being conducted in a microbiology lab. Suppose there are initially 7 bacteria in a petri dish. Make a table graph and an equation that will predict the number of bacteria in T hours. Label the scale on both the x and y axes. The increments on the x-axis should be 1/4 of an hour or less. Make sure you can fit at least 4 points on your graph. So what we're looking at here, time in hours, 4 periods of doubling per hour. So the number of bacteria when it starts is 7. Then we're going to take and so it's going to double every 15 minutes. So in an hour, it's going to double 4 different times. So this is a, oops. So if it doubles every 15 minutes, 7 and 7, that's going to be 14. Doubles again, that's going to be 28. Let's see. Doubles first 15 minutes. Sorry, brain isn't working. Okay, we'll get up to 112. Then we're going to take and go to the next hour, which is going to be 1,792. Notice we have some very large values here. For 3, it's going to be 20. Never know what this computer's going to do. 92. This one's going to be 28,672. Then we have 458,752. And then we have 7,340,032. Now, you understand what it means when it says it wants you to have 4 points. So you definitely have to do some crazy scaling on this to be able to fit those first 4 points on here, okay? So our equation is y equals 7 times 16 to the x, because we are going up by 16 each time. Sorry, that's weird. Don't know what it's doing. Numbers 9 and 10, you'll use the equation and or the graph to help you answer these. For 11, write a logarithmic equation that would allow you to find the time t when there are 700 bacteria. So maybe if this is right, log base 16 of 100 equals t. So we use the base of 16 to take, and we use the base of 16 because that's what we're multiplying by each time. And this should actually be a 700. Technology. 700 equals t, since we want it to be 700. And then t will be whatever the exponent is, which will tell us the amount of time. So then we can take and calculate that. You will take and do that yourself for number 12. All right, the next section. I don't know what just happened there. There we go. Sorry about that. So if we look here at this, we're using the properties of logarithms to find the value. You do not need to use a calculator for these. It's giving you different logs, their values, and what we want to do is find the log of 2/3. Now, 2/3, remember, if we split this, it'd be 2, the log of 2 minus the log of 3. So what we're doing here is we need to find a relationship that represents 2/3. So looking at our values here, 7 out of 12, no. 7 out of 8, no. But 8 over 12, that is the same thing as 2/3. So we're going to take 0.9 and subtract 1.1 from it. So we end up with a negative 0.2. So same idea for the rest of these. It's looking at our different relationships and properties to help us take and solve these. So like on 15, log of 7/8, well, we have both 7 and 8 here, so we're going to take the 0.8 minus the 0.9. That's supposed to be a 0.9. And we're going to get a negative 0.1. All right, so that is what you guys are looking at here, obviously on ones like these. So these are a little different, figuring out what we need to take and do to get this log base 8 of 729. So these are all log bases, but we need to figure out which one we can take and get an exponent for to get us, so 9 to some power, 6 to some power, 7 to some power, to give us 729. The only one that will get us 729 is 9 to the third power. So our answer would be 3b. So that's what we're looking at there, is figuring out what we need in order to take and get this value, okay? So same idea. This one you're looking at, okay, multiplying or taking it to some exponent. So like with this one, we need to take 9 to some exponent. So we're going to multiply 3 times the 1.06, since we know it's 3. Multiply that, and we're going to get 3.18. Okay, so the rest of these are for you to take and work on. Your keyword for this lesson is properties. Properties. If you guys have any questions, feel free to ask. Have a great day, guys. Bye.